testing, in mostly testing, but also creating continuous integration environment in IoT world. So let's start from working. From quick introduction, that's me. I mean, my name, the guy above, it's not me. So naturally, I'm from Krakow, and now I'm working in Kyiv for a company named PetCube. We are doing fancy camera for pets, with laser or treats launcher. It's quite funny. And last time we set up Ukrainka meetup in Ukraine as well. Actually, we can join and check because all the videos are in English. So maybe you will be interested. And everything I'm interested in, so pets, no surprise here. Traveling, no surprise here as well. And food, I hope it's surprise. Okay, let's start with smart sentence because it should work like that. So when we started adventure with IoT, it was almost 5 years ago. There was a big problem because it wasn't popular. So you couldn't just Google and find any already done solution. And at the same time, you had a lot of hardware devices, a lot of electronics to test and to combine into one single environment. About the definition, who can easily say that know what the IoT is? Who can define IoT description? Oh, come on, guys. Okay, so I will do. For me, it's like network, but for the physical devices. So we can send signals, receive signals, and transfer some data, and based on that, make some decisions. And I like that illustrations, so hopefully it won't happen, but I see it as one of the solutions for lazy people. So for example, for me. Okay, and why it's so important from my perspective? In 2016, it was 6.4 billion devices, IoT devices in the world. Just 1 year later, it was 30% more, so 8.9 billions. This year, it is not published yet, but it was 30% more than the previous year. So when you can easily calculate, in about 2025, there will be over 25 billion devices. Quite a lot. And how it looks like from my perspective. So usually, we have hardware and firmware on devices, so something physical. Then we have wireless communication from client side and from device side, any kind of wireless communication, or if it's possible, we can connect directly. So, damn it. Okay. Or you can connect like directly. For example, using Bluetooth connection. By the way, do you know what is the origin of name Bluetooth? Damn it. So because it's not working, I can say. Yeah, that's true. So there was a guy who really liked Vikings, and there was one of the most famous Vikings named Harald something, and in English translation is just Bluetooth. And okay, let's try. Yeah, so just to end up story, because I like it. Logo Bluetooth, very well known, are the two letters from alphabet, like of Vikings. It's, as I remember, H and A. Iceberg concept. It's quite well known because you can, for example, use it in a test pyramid or any social activities. My favorite is the one at the top you have success, and at the bottom, like 90%, you have sacrifice, hard work. You have like overworking, hard working, and so on. So actually, it's the same for IoT devices. So at the top, we have software. So customer or client side that can see functionalities, mostly functionalities. And for example, in case of lightning, it's dimming or changing color, the same with updates and connecting to cloud. But there is a lot of below. So the whole hardware layer, all the drivers, all engines that can control microcontrollers, and so on. And it should be checked, it should be integrated. And the same with firmware. So because it's like new technology mostly, damn it. Because it's new technology, okay, I will talk anyway. So because of new technology, there is a lot of low-level programming and low-level validation. And it became so popular that there are even dedicated conferences about embedded programming and embedded testing, or creating continuous integration for embedded. Oh, yeah. So, pains of tech companies, I will just try to speak. And sometimes you will see here. Because of new technologies, it's quite painful. Very often it's just startup, small company. So for you, the most important is time to market, not the quality of the product, just the speed. And because of that, you have always no time. So no TDD, BDD, any other fancy approach, no documentation, and not enough people, which is pretty obvious because if time to market, then developers first, like the pure developers, the guys who don't want to even test. Or very often it's dedicated for events. So you must somehow achieve the market. So your protocol, your device, your prototypes are dedicated for some events. I think the most known is CES. And the last thing, everything is chaotic because requirements can change every day because of some new specification, formal specification, like Bluetooth. That's the best example. And now, let's imagine the simple scenario. We have IoT environment, two bulbs, one switch, like you can turn on and off light, but wireless, and mobile application. And we want to just create network of that, and then turn off using switch, and turn on, or yeah, turn on using up, turn off using switch. Pretty simple, just 3 actions. When you break it down into components, it's not so simple, because before you start doing these activities, those 3 steps, you need to prepare the whole environment. So just automate it somehow to have already always prepared environment. And still, you have just a few bricks, a few blocks, and it don't have to be really hard. Unfortunately, it is. Just few challenges you have to deal with. How to always update new firmware on the device. For web applications, it's pretty simple. Like Amazon says, you can do it every 2 seconds. Thanks, Boris. For mobile application, actually you have store, you can update it anyway. For desktop, maybe a little bit harder, but still you can download and you can install the new version. For firmware, it's quite risky because if something goes wrong, your device can break, and then the only solution for the customers is to say hello and give you back the device because it's just not working. Then how to control it? We don't know to employ some students to click it the whole day, and we want to do it fast. the next thing, how to verify if those bulbs were really turned on or turned off. So validate the real behavior. And finally, how to aggregate all those results and then put it somewhere and store the results. And of course, much more. And all those components have to be took into consideration when creating environments. So you see a lot of physics. It's embedded, it's hardware, it's firmware. And it wasn't simple. Now I can say it took like 3 years to create the environment. But somehow, let's try. So we had a lot of pains. Now, how we can deal with it? I said we did it. So that's the story with happy end. Following common methodology. So that's the first thing. Let's just skip time to market priority and mostly focus on creating the company culture that brings you like easy work environment. Then facilitating external processes, and you can do it, for example, by introducing Scrum, Agile. Actually, I'm not a lover of any of them. I mean, I like to adopt it, so Agile from the definition is to adopt it. Automation tools freedom. Well, I said there were no ready solutions, so very often you should create it on your own, or just combine a few of them, or use any open source. But you shouldn't be forced to do it. Then, of course, consider architecture, brainstorming session that is my favorite way of generating ideas among the team, hopefully smart people, and then team autonomy. Let's look at the big picture. It's very popular now, it's almost obligatory to put everything into cloud. Unfortunately, instances that consist of hardware cannot be put there. And the reason is pretty simple. You cannot send your device to Amazon and say, hey guys, just connect those two devices, please connect. And then if something went wrong, just set them, hey guys, could you reboot my device? No, it must be connected locally inside the company. And because of that, we need to put mobile devices as well, because they need to communicate in wireless way. The rest instances can be put into cloud. But those two, in my opinion, shouldn't be, or mustn't. So there is no other way. It must be automated. If not fully, then at least partially. Some processes, for example, preparing test environment. What are requirements for that kind of environment? So firstly, cheap. And it's not surprise, small companies, high-tech companies, we want to sell something, we do not earn money because of investors, so we have Series A, B, C, but we still don't have product. So we should save money. Then simplicity is pretty obvious, like for any software development. Modularity is the same. We have everything inside the company, and it should be easily migrated between. Scalability and reliability as well. Let's start. Let's prototype something, and let's try to build it. And actually, I like it because not the head of horse, but here you can see like how the real environment of IoT table looks like. And you can try to clean it, and it's my good explanation that it makes no sense, because after 2 days it will be the same. Model flashing, how to constantly do it. The problem here is to be 100% sure that device is updated, you should connect it in a wired way, not wireless. And to do it, you need some device that will do it. What are requirements to choose? I suppose, again, money. The cheapest at the time was Raspberry Pi. So just connect it to our master instance, and then connect it to devices. And that's it, like a couple of wires. The only suggestion from my side, you have devices connect to 230 or 220 or 110, it depends on the country. And if you do not isolate or separate it, there is a nice explosion by the end. That's not what we expect, really. I mean, it's nice to see it at least once in your life, but the second one can be very painful for your company and for yourself, of course. This is how it looks like, and it looks scary. So this is what I did. It's awful, I can say now. But this is just one of solutions. There's this dirty, cheap solution. Yeah. The second solution could be to buy already done device on the market. It's pretty expensive, but you have it in a couple of seconds. And there is solution in the middle, so you can send it to third-party company or employ someone who will develop that kind of tool. Okay, we need to somehow control that switch. So using any embedded platform, we have just 4 channels. You can use 4 GPIO outputs. It's simple, 0 or 1 signal. And you have 4 channels. So the first thing is to turn it off and turn it on. Then you should inherit it, and you can include time. So you can dim, so increase or decrease the value of lightness. And the last thing are some combinations. So what is important for IoT? For example, energy saving. Because it's battery device mostly, the device is not advertising. You cannot see it in the air. And to wake it up, usually it's like the special sequence. Okay, next slide. Vision system. Oh, it's perfect. And the previous one looks like that. So you just inherit the next instances. And the implementation in that way is pretty simple. You cannot just get lost. Vision system. So this time we want to verify our real behavior. So as a simple flow, we have the initial state, then we change something, and we have the bulb. Like you can click turn off bulb with switch on the wall. Again, it's dirty, cheap requirement. So this guy is dirty after this job. And of course, you can send it to third-party company, but it's surprisingly very expensive. And the main requirement here is to isolate it from external influences. For example, lighting environment. Yeah, you can. There is day, there is night. You cannot change it. Sorry. And if there is day, it can influence a lot. So what you can do is not just separate it, but also use some fancy things like black paint, because it do not absorb light. So if we have that, we have matrix with bulbs, we can somehow verify it, put the hood on that, and then you have image like that. And the last state is extremely satisfying. You just read the value from matrix 3 on 3, so you have 9 values in RGB scale. Perfect. So we have environment. Now time to code. So my imagination said like, this is the solution. I trigger a signal, I gather values, I can create some next step. And this is the reality. So when I started vision system, when I started vision processing, it's not so easy. So from one side is this like disclaimer from my side. Just you need to anyway spend time to learn. But when you learn it once, it can bring you value, especially that it was about 40% of IoT devices works with lighting environment in industrial spaces, in commercial spaces, or in private spaces. And this is how it looks like. So this is a good example. We have 9 values, and then we can just read it's it's just black-white scale, so grayscale actually is transformed. One thing, we should always take care of setting cameras, because if you do it wrong or you didn't care about it, after every reboot, so disconnect and connect camera, it will turn on automatic values. So just keep it somewhere into configuration file. We have those 3 components. Now let's try to implement test cases. This is panel of mobile app, so it's front for the customer. Actually, it can be anything. It can be web, it can be desktop application. And remember, we created a very simple test case, turn off, turn on bulb. And then we created environment that actually covers those requirements. And having that environment, we can create almost 20 test cases. Now, how it looks like. At the top, we have test arbiter, so something that can control and glue our results and then make some decision. We have mobile app, which is well known. We have camera controller, so one to keep configuration and second to process image. Then you have our switch environment, so based on clicking, and REST API, which is well known as well, to gather firmware from the cloud, so after every new build. Let's try to implement test cases. That one is pretty simple. We reset switch, then we wake up, add device, and check on a list. What is the value here? That you read that and you know what's going on, even if you are not very deep into hardware environment. Another example, factory reset switch using hardware. Yeah, usually we have 2 solutions. One is hardware, and the second one is software solution. So you can reset any device or remove configuration using front end for the customer or using some sequence on a device. And in that case, we have hardware solution. The first line is totally unnecessary. The second line is just, again, waking up, then adding device, and then trying to make factory reset and check if it's advertising again. And the last example is sharing. So it's sharing our configuration to any source, Gmail or Drive. Okay, that one is not so cool. Actually, I'm sure we need to spend time to understand it. But we don't like to waste our time. And the solution here, can we just make another layer of abstraction and use BDD solution? And here it's pretty understandable. We have devices, then wake switch up, and make some association. So for one channel, we set up bulb, and for the second, set up nothing. Then we make sequence, turn on and turn off the second channel. And then we just want to check our logic. So first bulb should be on, the second one should be off. Cool. And this is architecture of the whole environment. We have our test arbiter. We have those 2 machines locally. So as I said before, it's hard to send our devices to Amazon and ask them to give us a favor. Then we have real devices and connection with embedded platforms. Just some numbers, because we like numbers. So yeah, it took a lot of time. It took almost 3 years, but we had only 3 people to implement everything. Now it's much more, now it's about 15. So it's cool, yeah? When you start selling product, then from 3 people you can make 15. And now it's like much more complicated. And the final result, so what the product people can see, what the business people can see, so what they are really interested in. if it's green or if it's red. Voila. We have red, green, orange communication with business. So we did it. We did it. It's done. It's done for the simplest solution, but still, thanks to that, we can create much more sophisticated test cases. Now, some takeaways from my side. The first thing, as you have seen, you should start thinking very big through the picture of architecture, but start acting very small. So for me, it's like building Lego construction, brick by brick. Now, if you have one platform to update firmware, you can scale it to another, you can put another devices. For a vision system, it's the same. You can easily scale it, you can easily extend it. Iterate and refine. So if it explodes once, do not try the second one. Or you can try with another device, but it can be very costful. And then, as agile methodology says, iterate and refine your approach. Maybe that one was not very correct. Maybe there is something better. Maybe some of your colleagues know something better than you. It's hard to believe, but maybe they know. Unleash team creativity. And that's one of the solutions. And I mentioned my favorite solution is brainstorming. So among those 100 stupid ideas, there can be one very smart. One very smart that can decrease your value, your creation of that environment by multiple times. And that was the case with putting external embedded platform to flash it. That was that one golden advice. Interoperability. So we know that's important. In that case, it's very important. Modularity. Actually, that's very similar to looking through the big picture, but starting working small. So building our construction from the small bricks. And when creating requirements, creating test cases, it's very nice to focus on risk. So look through the risk perspective. What is the most risky for IoT? From my perspective, is always update. So OTAU is over-the-air update. If you have, like in my example now, almost hundreds of thousand devices, and there is a small leak in your firmware, and you send it to 100,000 devices, that's nice, but your company cannot not exist anymore. And physics. Who likes physics? Wow, cool. So you can start your adventure in IoT. Or maybe you already did. Yeah, and it's surprising. So once we had very painful, yeah, it's literally painful, because every touch to device, it kicked you. And if it's 5 volts, that's not so bad. If it's 12, that's not so bad as well. If it's 230, I prefer not to touch. But you need to develop. So we spent, as I remember, almost 3 months investigating from a software perspective, hardware perspective, design perspective. And what was the solution? There was, the humidity was not enough. So we, like, the device that produce, like, let's say water into the air. So we just bought it. We just bought one humidifier, and that was enough. So it cost us about $20 when we spent 3 months trying to investigate it. So it's hardware, and you cannot change it. Like, you cannot change it day and night. You cannot change hardware. It's also IoT. And the last one, security. And that's the most important, and that's why I didn't say anything. And that's why I encourage you to explore it on your own, to check how important is security in modern world. Who heard about Mirai bot? Okay, it's actually the biggest attack in, yeah, it's the biggest attack of bots in, I think it was last year or 2 years ago. So the point is they use brick in one device, IoT device, to get access, and then get access to tens of thousands of them. And they generated the highest transfer of data in the history of internet, just because of one brick. So there is, you can check it, it's pretty fine. There is every year a list of the most scary, the most funny, and the most painful bug. And most of them regards to either public cameras or some IoT devices. I remember last year the most scary was the, it was Barbie, like for children, and because of some brick, there was a guy who put just screaming voice into this toy, and yeah, that's funny from sorry, that's scary for the parents, I suppose, and even more for the children. By the way, I don't know how strange you have to be to put that scream into toy, but people are strange, and that's actually the conclusion is security. It's quite important. And that's everything from my side. You can catch me whenever you want, especially at the after party, I hope. You can find me here, or you can join our group. If you have any questions, feel free to ask.
Thank you, David, for your sharing, for your experience. I personally have a few questions for you. First of all, do you calculate return on investment for a particular framework? What is the numbers?
I don't know if we have time. So my answer is I answered quickly. When we created that, there was not a product, and there was no money to calculate. Everything was from investors that were constantly filling our wallet. And yeah, for me that was surprising. After 2 or 3 years, they didn't stop, but that's cool, that's cool. And now, because there is product, so we don't have such calculations yet. Actually, it's based on Bluetooth Mesh protocol, which is pretty new because it was released, I think, 3 months ago officially. It's like additional layer for Bluetooth 5.0. So you can ask it next year.
Okay, thank you. And my next question will relate to type of test that you performed. Right now you show us that you focus on end-to-end test.
Yeah.
Do you have any other level of tests?
Of course. So the whole pipeline is pretty complicated. So you start with unit tests, and coverage of unit tests for firmware, usually it's quite broad, so you have a lot of them. Then you have mobile application, quite well known, unit and component, and the same for hardware. With firmware there is another story, so we have the lowest level, it's called stack, mostly based on simple logic, and based on bits and bytes. And then you have functional firmware. So then you can create work on the real devices, but you need to create separate tests. Then you have integration of those two firmwares and integration between devices, and that's what you have seen. And that's the most interesting because you see results. But yeah, definitely. You cannot just execute it before you are not sure that firmware is working.
Okay, thank you. And my last question regarding updating firmware strategy. How you do this? You say that if you have 1,000 devices, you're not eligible to update all of them. So what is your strategy? Could you please share?
Yeah, so it's of course wireless update, because you cannot do it in another way. For testing, it's wired to be sure it's working. For the market, it's wireless. And it's pretty simple. All the devices communicate with backend, and then reporting status. If you set the new firmware version, the update just starts. So any scripts run on the cube are just any scripts on a cube are just run, and then downloading new firmware and reboot it. And after reboot, there is a procedure to update the whole image. Usually, it's much over 100 megabytes, so quite a lot.
Okay, thank you. Guys, if you have any other question.
Thanks for your talk, and I have a question. As you said, for prototyping, it's dirt cheap. You can just buy some modules, then hook up with wires, and start to testing something, some to develop and testing. But if we're talking about mass production, we can't escape from producing some custom PCBs, some custom devices. So do you have any experience when you are testing something on your prototype, then you've got complete device, production prototype, and something gone really strange with testing?
Yeah. And
can you tell some of them, please?
Sure. So that is very good question, and that is very good topic for another presentation. So when you have all the tests done inside the company on the prototypes and so on, so you don't have device that will be produced for the customer because it is not done yet. So then you have, and then we can call it testing on production. So you have production in China. You have assembly line, you have 50 Chinese people doing that and testing one by one device. And usually you have 3 stages. It's called PVT, it's called DVT, and it's called MVP. So it's design, validation process, then it's PVT, I forgot the abbreviation, something validation process, and MVP, it's mass validation process. So you just have usually initially just 10 or 15 devices to check, then you produce, looking for problems, usually inside the company, so that's get back. Then you prepare tooling in the manufactory, so you have it already set up, execute another few hundred of devices, some of them are returned to your company, and usually you find some problems, hopefully. And then you can start mass production. That's right. But you should always keep kind of safety buffer. So do not put all the functionalities inside that kind of chosen firmware, because you need to put initial firmware on the device and then send it to customer. So it should be like the most stable you have. You don't have to be the one that passed all the tests at your company, but better to put something that is surely stable and was on the market already. And then if you start production and you have throughput like 500 or 1,000 devices, that's bad if you find something. Then you have something called Anton cord, so you just pull the trigger and everything stops. And the Chinese people are like bored. And you are paying them, but it's like wasting money for you.
Thank you for the answer. Guys, who else?
Thank you for the presentation. You mentioned multiple times that you had a constraint related to the to costs. So you had to make everything the cheapest possible way. So if it were possible for you to have an unlimited amount of money, how would you organize the workflow, CI, and so on for the hardware?
I never thought about it.
Yeah.
It's like I like to dream about something and make a lot of imagination, but it's just impossible. But let's assume we have that money, and we have good people who wants to work for that money. So yeah, there is a lot of already done solutions done by big. Oh, I forgot the name. For example, for Bluetooth, it's Nordic Semiconductors or Texas Instruments. You can buy very fancy tools, and it will do everything for you. The problem is money. The problem is money that if you will spend, I mean, you can spend, but it will cost you probably salary for 10 people. So you can buy it and then let people, hey, you have month break. Yeah, but if I would have unlimited amount of money, I would just invest in already done solution, because then you can speed up. Instead of 3 years, probably it can take 6 months. And integration is painless, because you do not have problems between integration of the single components.
Thank you.
Just curious, how many devices did you burn or destroy during the prototyping? And what's the average device die rate during your daily work? How many per month?
I love the description. I will introduce die rate.
We have the die rate when our customers tell us to die in the reviews.
Yeah. So during the testing, it's not a problem. Prototypes, usually, if you have 10 prototypes, it's like standard amount at the beginning, 10 PCB boards. By the end of test, we had like 6 or 7 still living. It's not bad. It's pretty cheap. It's worse when it's on a customer side. Then on the production, in the first stage, it's pretty similar. Last time it was 3 per 10, but it was the first stage. And then if it's for the customer, you have some, it's called AQA table. So it's like the number of faulty devices when it's on the market already. And for that kind of devices, as I remember, is 0.8%. So it's less than 1 per 100 devices.
Great results.
Yeah, so one more conclusion from my side. It's much better to burn in a phase of prototypes, not because of, I mean because of money as well, but if you have already done device, it's closed. So you have fancy design and so on. In prototyping, you have just pure PCB board. You can see fire, smoke, and so on. So yeah.
You cannot easily change the production line afterwards.
Unfortunately.
Thank you for answering. Guys, who else? Okay, thank you very much once again.
Thank you.